Greetings, math friends. Today we are taking a look at Topic 2, Lesson 1 in Intensified Algebra. And this lesson is covering the notions about your math ability. Now, the first thing I want you to do is turn your book to page 45, and I want you to complete the survey in your book. Or if you're working out of a packet, it would be, Topic 2, Lesson 1, the first page. So pause the video while you fill in the answers to these questions. Questions 1 through 11 in this table. Okay, thanks for filling in that table. Now, after you've completed this survey, please reflect on the following questions. How did these questions help you think about yourself as a learner? What kind of a learner do you think you are? What patterns, if any, did you notice in your answers? Was there any common themes as you answered the questions? And what conclusions did you come to about yourself as a math learner? How do you feel about yourself as a math learner after filling in that survey? Today's lesson, we're going to focus on the following. We're going to examine and reflect on your perceptions of your math ability. We're going to learn about how intelligence is malleable and not fixed. Malleable means it's able to be changed, and fixed means solid, steady, unchanging. So your intelligence is malleable, not fixed. And we're going to understand how working on challenging problems affects the brain. Our core activity, and it won't take 30 minutes. Have you ever wondered what's happening in your brain when you work on challenging tasks? In this topic, we're going to investigate recent scientific discoveries about the human brain. Some of them just might surprise you. So, ask yourself these questions. How do you define intelligence or smartness? Do you think people that are born with a certain level of or amount of smartness, are they born with, it's like everybody's just born, you're going to be this smart forever? Do you think that smartness changes over a lifetime? Or do you think it stays the same? Now, you might not believe this, but people generally believe one of two opposing viewpoints about intelligence or smartness. Some believe that intelligence doesn't change much during a person's lifetime. They're wrong. In this topic, we're going to explore scientific proof that a person's intelligence can and does change. People used to think that we're born smart or not smart, or somewhere in between, and we remain at this level of intelligence for an entire lifetime. But it turns out that this view of intelligence is incorrect. It is wrong. Regardless of your age, your background, your ethnicity, or gender, it's possible for any and all students to increase their understanding, to expand their capacity, and to get smarter in any subject. Research has shown that you have control over your own intelligence and understanding in any subject. Thousands of former students have experienced this for themselves, and you can too. So the question is, how do you get smarter? As you may have guessed, learning involves the brain. And it turns out that the brain is much more flexible than anybody ever imagined. For example, when you work really hard on something new, your brain actually gets more complex. This means that it grows new and stronger connections between neurons. What are neurons, you ask? Well, neurons are special cells in the brain that transmit information. And it turns out that when the brain becomes more complex, it's easier for it to transmit information, and you get smarter. Now, your brain is made up of approximately 100 billion special cells called nerve cells or neurons. The main function of neurons is to transmit information or messages, like electrical wires or fiber optic cables. A neuron has many parts, including a cell body, an axon, and dendrites. So, what you see here on the left is a brain. And inside this diagram is, you see this little box right here. Well, this little box, if we expand it, make it larger, is this picture right here, so we can get a close-up view of the brain at that particular point. So now the cell body acts as a command center and helps maintain the cell. All right, so what we've got here, what you see, these are cell bodies. Okay, those are command centers and they help to maintain the cells. All right, now the next thing you see are the axons, and axons carry information away from the cell body and direct it to other neurons. And so your axons are these lines here. They're large because they are sending out lots of information all the time. Okay, so they carry information away from the cell body and direct it to other neurons to make connections. All right, so they're constantly transmitting information. And dendrites are these legs that we see. All right, so dendrites, let's see, we'll do that in this color. So these are the dendrites. Okay, dendrites are these legs here. All right, dendrites. Right, dendrites receive information from other neurons and then carry it to the cell body. So you see this axon here is sending out information, sending out information to these dendrites, and the dendrites carry it back to the cell body, and the cell body processes the information. Okay, now when information is sent from one neuron to another, it flows across a gap called a synapse. Right? There's this gap here between the axons and the dendrites. They're not actually connected. There's a gap. And a gap is kind of like the gap in a spark plug. And as information moves from across the synaptic gap, from the axon to the dendrites, is communicated by chemicals called neurotransmitters. How great is that? Neurotransmitters. And so that's how the information gets passed from one cell to the other in your brain, from the axon to the dendrites, across the synaptic gap using neurotransmitters. So let's use these terms provided to complete the sentence frames. Now, what I need you to do is use this box of terms to fill in these sentences. Take a moment, stop the video, or pause the video and fill it in. I'll be back in a moment. All right, thank you for filling that in. Great job. Let's see how you did. Now, the main job of neurons is to transmit information or messages. That information is sent from one neuron and flows across a gap called a synapse to the other neurons. The axons carry information away from the cell body, and the dendrites bring information to the cell body from other cell bodies across the synaptic gap. Now that you're familiar with what a neuron is and what it does, you may be wondering what neurons have to do with getting smarter. Well, let me tell you. So the question is, what happens to your brain when you learn new things? Your brain changes. This is the answer. Your brain changes by becoming more complex. So, why do we sometimes struggle when we're learning something new? Scientists have discovered that when we learn something new, it's more difficult for the brain's electrical signals to cross the synaptic gap. But we can strengthen brain connections to make signals transfer more easily. This makes challenging tasks easier over time. We're going to play this video to learn how. Give me just a second here.
As for every single one of us, learning something new means rearranging the way her brain works. Our brain has an astonishing 100 billion neurons, or brain cells, all connected together. Learning is about creating and strengthening pathways through these neurons for impulses of electricity. But between each and every connection in our brains, there's a tiny gap called a synapse. For any of us to learn something new, the electrical signal has to jump across this gap to continue its journey. The gap between the two brain cells is tiny, but that doesn't mean it's straightforward for a signal to get from one side to the other. For us, it's like crossing a deep ravine. And getting from one side to the other should tell us something about the way we learn. The first time a signal crosses from one brain cell to the other demands the most effort, and it's the same when we cross our ravine. The first trip across is the hardest. Having crossed the ravine once, the journeys across get easier and easier. And a similar thing happens when we learn something. To start with, learning is difficult. But as the signal crosses the gap between the brain cells again and again, we establish a more solid pathway. Sorry about that. By the time we've made the crossing over and over again, it becomes effortless. We can do it whenever we like. We finally learned something.
All right. So that's a great representation of how your brain works. So what happens to your brain when you work on a mathematics task? Whenever you do any kind of task, your brain uses neurons to send information. When the task is easy, a task that you do a lot, for example, the information travels easily. Oh, let's see, from 5, here's the sequence, 5 to 9, that's plus 4. From 9 to 13 is plus 4, so the next one's going to be plus 4, so that's going to be 17. Plus 4 more, that's going to be 21. Easy peasy. But when the task is hard, or when you try to learn something new, it is harder to send that information. Oh man, from 2 to 5, from 5 to 10, man, I don't know. What happens? I'm so frustrated. So if you work at the hard task and practice, new neural pathways form and your understanding increases. Your brain changes by developing more complex and stronger connections between the neurons. One way your brain becomes more complex is through individual neurons sprouting new dendrites. Okay? New dendrites and axons. Kind of like how a tree grows new branches. So we can see in this original one, we've got this axon here, right? And these dendrites right there, right? But in this picture over here, we can see that same one, and here's that original dendrite, right? Those are there, but in addition to that, we've got new connections that have been made. Not just the original ones, lots more connections. So an increase in dendrites and axons means an increase in locations where synapses can form. And when you have more synapses forming, the pathways among the neurons becomes more efficient. The information travels along a network of neurons in much the same way as people travel between cities on roads and highways. Like a system of roads, the networks of neurons become stronger, more efficient over time, and travel becomes easier. Neurons build superhighways. These changes in your brain mean that everything travels more easily between the neurons, and the task that was once difficult becomes easier for you. In addition to growing new connections, neurons get in sync. Over time, it takes less energy for each neuron to send information to other neurons on these efficient pathways because they sync up and become linked in a more efficient way. Now, scientists used to think that as people grew old, the brain's connections became fixed and unchangeable, but now research has shown that the brain never stops changing. People can learn at any age. No matter how old we are, we can form new connections in the brain and strengthen existing ones. And there's particularly good news for you. At this time of your life, it's especially easy to grow your brain. Adolescence, which is where you're at, and infancy. Now, you're not an infant anymore, but you're in your adolescence. You're in the prime time to be learning new stuff. So, don't shy away from challenges. Challenges are how you learn. All right, now let's see what you've learned. Use this word bank to complete the sentence frames about your brain. Go ahead and complete this task in your book. Pause the video, and we'll see how you did in a few minutes. All right, thank you for taking care of that. Now, the brain physically changes when you learn. Adolescence is especially easy time to grow your brain. Stronger and more complex connections make information transmission easier. New and stronger connections are made when you work hard at something new. When you work harder, you get smarter because your understanding increases. Okay? That's the whole thing. The harder you work at something, the smarter you get because you're increasing your understanding. Don't shy away from difficult tasks. That's the message here. All right, now what I want you to do is the practice work on pages 48, 49 in your math book. If you don't have a math book and you're working out of the packet, it's the homework that goes along with Topic 2, Lesson 1. Thanks for watching. Have a great day. Don't forget to be awesome. See you next time.